What is the electronic geometry for the molecule nitrogen trifluoride? We have those 5 different choices. Okay, first we need to find out the total number of valence electrons in this molecule. Nitrogen, so that's in group 5A, so therefore should have 5 electrons, valence electrons. Fluorine, that's fluorine, in group 7, so therefore should have 7 valence electrons for each fluorine. And then the total, 21 plus 5, 26 valence electrons. Okay, so if it's 26, okay, obviously we have 1 nitrogen and then 3 fluorine. So we should be able to draw the structure. Okay, that's a 3 bonding. All right. So 3 NF bonds, NF, NF, NF. Okay. So far we have assigned 6 electrons. We still have 20 remaining. All right. So still 20 valence electrons remain unassigned. But first, we need to assign those valence electrons to the peripheral or surrounding atoms to satisfy the octet rule. And now, as you can see, each fluorine should have 8 electrons, all right, surrounding it, okay? And now let's count the total number. I mean, so we have 20 remaining, but let's see how many lone pairs we assigned so far. That's 1, 2, 3 lone pairs, and then this translates into 6 electrons. Okay, then we have 1, 2, 3, 3 times 6, that's 18 electrons. 20 minus 18, so we still have 2 electrons remaining unassigned. And now, of course, we have to assign those to the central atom as lone pairs. Okay, and now you see we have all of 26 valence electrons assigned. Okay, so it is asked what is the electronic geometry or electron group geometry or electron pair geometry. They're all the same. So based on the electron groups. Okay, how many electron groups do we have now? We have 3 bonding groups and 1 lone pair group. All right, a total of 4. If it's total of 4, the geometry has to be tetrahedral. So therefore, the electronic geometry is tetrahedral. Okay, so even though we have already solved this problem by now, but I would like to ask an additional question. Let's say, what is the molecular geometry for this molecule? We know the electronic geometry is tetrahedral. But what is the molecular geometry? Molecular geometry, we only focus on the atoms. Or in other words, the atoms that, are involved in chemical bonds, the bonding ones, all right? So, and then, of course, this lone pair, there's no atom there, so it does not show up really in the shape of molecule. So therefore, what we have right now here, we have the trigonal, actually you see, trigonal pyramidal. Of course, it does not have a choice in here. But if it's asked, that should be trigonal. That's a triangle base, and then that's a pyramid. Okay,